Okay, this is another instructional video on how to find the volume of a solid using the washer method. Except instead of dy this time, we're going to use dx. So, we know that the volume equation is the integral of f of x squared pi minus the integral of g of x squared pi. So, basically all we got to do is plug and chug here. So, the volume of the solid will equal the integral of f of x would be x equals 1, and g of x would be x minus 1 squared, because you have to take the bigger number minus the smaller number. And if we rotate this around, we're going to get something along the lines of this. And so our washer will look like that. So the higher rate, or the bigger radius, goes all the way out to x equals 1, and the smaller radius goes to x minus 1 squared. So f of x is equal to the square root of x minus 1, all this squared, times pi, minus the integral of x minus 1 squared, and it's squared again, pi. And then it all equals dx. Alright, now we need to find the limits. So, you can tell by the graph that y equals the square root of x minus 1 crosses this y-axis at 1, 0. So, we know that the lowest x value is going to be 1. So we can put that down for the limit. And then, in order to find this point right here, we have to set these two graphs equal to each other and find out what x value that is. So, we have to set the square root of x minus 1 to x minus 1. And then you'll solve for x, and you'll get x equals 2. So then the top limit is going to be 2. And then we can simplify this integral and just say pi times the integral from 1 to 2 of the square root of x minus 1 minus x minus 1 to the 4th power. Oh, it's the square root of x minus 1 squared, which is the same thing as just x minus 1. Alright. And then dx. And then you solve for volume, and you get... Alright, so if you solve for this integral, you get the volume of the solid equals 3 pi over 10, or 0.3 pi, or 0.942. And that's how you find the solid, or volume of solid, using the washer method.